Okay, so with this graph transformations, right, there's certain things you need to learn with graph transformations. If you're adding something on, right, in this case, you shift the graph up, right? So think about this. If you've got like f of x, okay, which just represents the curve, right? That's what f of x is. F of x is this curve, right? So f of x at this point would be whatever the y value is there. So suppose y is 6 there, well, that's what f of x is there. If y is 2 here, well, f of x is 2 here. It's just the curve, right? That's what f of x is. And if we're going to say add 4 to it, we add 4 onto it. So if that was 6 there, that y value, well, we add 4 onto it, so we end up being 10. So this gets shifted up. Here, look, right? The value of f of x is 0, isn't it? So if we add 4 onto it, it gets shifted up, and it gets shifted up to 4, right? And that's what I'm going to do there. I'm going to mark it there, and it does say, doesn't it, where it crosses the y-axis, write down the coordinates, right? Or mark down the point there. So it gets shifted up 4, and the whole thing gets shifted up, and you end up with your curve like that. That's your f of x plus 4. So it's important to remember, if you've got f of x plus a number, any number, a for instance, you know, to represent the number, you shift it up by a. If it's a minus number, right, if it's a minus number, you take it down, right, so you'd actually take it down by a. Okay, so it'd end up down here. You mark the number then on the axis. Okay, so here now part B, this is y equals g of x, and then it says 4 times g of x. So think about what we're doing here now. We multiplying g of x, yeah? That's what 4 g of x means, 4 times g of x. Okay, remember g of x just represents the value of the curve, the y value. So if we're multiplying it by 4, it gets 4 times bigger, doesn't it? Yeah, it gets 4 times bigger. So now, you know, take this for instance here. If that value there of y is 1, right? If that's 1 there, right, just making this up, but if it was 1, we multiply that by 4, it'll be 4, won't it? So it'll be up here. So basically, that curve is going to be stretched, right? Okay. So this value here, suppose that was, I don't know, 2, well, you multiply it by 4, that's what it's saying, 4 times g of x. So 2 multiplied by 4, you end up here somewhere, wouldn't you? Okay, so what happens is, right, is that this starts to increase ever so quicker, right? So it's like that, right? It doesn't have to be perfect, but just as long as you show that it does rise quicker. Now, in terms of negative values here, well, if that was minus 1 here in the y-axis, well, then you times it by 4, so it'd be minus 4, yeah? So again, we'd be sort of down there, so maybe turn it around, be easier for me. We end up with that there, okay? So then we label it then 4g of x, right? That's what we've got there, y equals. Next one then, right, now, this is a different kind of transformation because notice the number we're doing here or adding on here is in the bracket, right? Now when it's in the bracket, okay, it doesn't affect the y values, it affects the x values, right? And that's so important. So you will go into what it says here, x plus 3. There's going to be a movement along the x-axis, okay? You're going to affect the x values. But what's really fascinating about this is, right, really fascinating, is if it says add 3 to the x in here, right, you do the opposite. So you actually take away 3, okay? So you actually move it in the opposite direction, okay? And that's so important to remember. So if you've got, for instance, you know, this in general, right, a is a number, then you actually, because it's positive there, you actually shift it in the negative direction by a, right? And if you had it as a minus a, right, if it was minus a, well, you do the opposite. You'd add, you'd move it this way, in a positive way, all right? So in this case now, it's got h of x plus 3. Well, because it's plus, we go in the negative direction. So it goes from 1, there, it'll cut it at 1, but if you move it back 3, it'll cut at minus 2. Okay, minus 2 then. It's important you write down minus 2. As it says to indicate the coordinates of one of the points on the curve. So that will do that. And then we just got to draw that curve, turn it round. I find it easier. We turn it round. Something like that, right? And you've got then this shifted, but it's shifted this way, yeah? Because it's plus 3, you've got to go the opposite.